Hello, Focus Learners, and welcome to today's Explainer. I am absolutely thrilled to guide you through this one because, let's be honest, we're tackling one of the most transformative technologies of our lifetime, artificial intelligence. But look, we aren't just going to hover at the buzzword level today. No way. We are journeying all the way from the absolute foundational concepts of how machines learn, right down to the literal silicon chips humming inside Amazon Web Services that make the whole shebang possible. So, whether you're looking to classify your mental models or finally connect the dots between foundation models and the cloud infrastructure powering them, you are exactly in the right place.
Okay, let's quickly look at our game plan. First, demystifying the AI umbrella. Second, generative AI on AWS. Third, mastering prompt engineering. Fourth, how AI makes predictions. And finally, hardware and measuring success. Let's dive right in. Section 1. Demystifying the AI umbrella. Time to strip away the hype and figure out what it is we're actually building here.
Before we even think about cloud architectures or prompt engineering, we really need to ask ourselves a fundamental question. What exactly is artificial intelligence? It's a phrase that gets thrown around so much these days that it's super easy to lose sight of the core definition. So let's anchor our understanding right here before we start getting into the technical weeds.
Here is our foundational definition. AI is essentially a broad field of computer science dedicated to developing systems that solve problems typically requiring human intelligence. We're talking about things like perception, reasoning, decision-making, and learning. But here's the absolute crucial takeaway for you. Artificial intelligence is really just a giant umbrella term. Beneath this massive umbrella, you'll find a whole bunch of nested techniques that we use to actually make machines think.
To really put this into perspective and see how far we've come, let's travel back to the 1970s. Researchers built the MYCIN expert system to diagnose patients. It ran on yes or no questions. Well, specifically, it was a collection of over 500 rigid rules. It would ask a question, follow a predefined logic tree, and spit out a cure. Sure, it was artificial, but it definitely wasn't machine learning. If a patient happened to have a symptom that fell just slightly outside those 500 rules, the whole system just broke down. It simply could not adapt.
Zooming in a bit further under our AI umbrella, we hit deep learning. And this is a real game changer, because this is where we completely ditch those rigid manual rules. Instead, deep learning literally mimics the biological structure of the human brain using virtual neurons and synapses. And because there's more than one hidden layer of learning going on, we call it deep. It processes incredibly complex patterns, like picking out a specific face in a crowded photo or translating languages on the fly. This is absolutely vital today because it's the engine behind almost every modern tech breakthrough. But, as you might guess, mimicking a human brain takes some serious computational muscle. That is why it relies so heavily on powerful GPUs, or graphical processing units.
And that brings us to our final nesting doll under the AI umbrella, generative AI. For decades, machine learning was mostly about classification. You show a model a million pictures of bicycles, and it eventually learns to classify the next picture as either bicycle or not bicycle, right? Well, generative AI totally flips the script. It takes everything it has learned about the very concept of a bicycle and gets creative. It can generate a brand new, never-before-seen image of a bicycle, or write a poem about one, or even write the computer code to animate one. It completely stops just classifying data and actually starts creating it. Section 2. Generative AI on AWS. Now that we've got those macro concepts down, let's look at how they're actually built, hosted, and accessed out in the real world using Amazon Web Services.
So, building generative AI applications from scratch used to be ridiculously difficult and incredibly expensive. But then, enter Amazon Bedrock. Bedrock is a fully managed service that essentially removes all of the heavy lifting. I mean, there are 0 servers for you to provision or manage. You just interact with the models through unified APIs, and you literally only pay for what you use. But here's the best part, especially for businesses. You maintain complete 100% control over your training data. It stays perfectly secure and private. So you don't have to worry about your proprietary information secretly training someone else's public model.
And when you're using Amazon Bedrock, you aren't just stuck with a single AI brain. Bedrock gives you this massive menu of world-class foundation models to choose from. For instance, you've got AI21 Labs and Cohere, which offer these absolutely incredible models known for highly sophisticated text generation, summarization, and natural language understanding. But it doesn't stop there. You also get access to industry heavy hitters like Meta's open source models and Mistral AI. And because Bedrock uses that unified API we talked about, you can seamlessly swap between these models without having to rewrite your application's underlying code, which is huge. It means you can mix, match, and customize the absolute perfect artificial brain for your specific business problem, perfectly balancing capabilities, speed, and cost. Section 3. Mastering prompt engineering. Having these powerful models at our fingertips is great, but now we need to talk about the practical, day-to-day skill of how we actually talk to them to get what we want.
The difference between a naive prompt and an enhanced prompt is night and day. If you throw a lazy input at a model like summarize what is AWS, you're inevitably going to get a lazy, super generic output. But an enhanced prompt? That's different. It defines the audience, like saying it's for beginners, and explicitly asks to focus on key services. Suddenly, the model has a very precise target to hit. With generative AI, it's pretty simple. The quality of your output is directly tied to the quality of your instruction.
So how do we guarantee that quality every time? Well, here is the exact anatomy of a flawless prompt. To get the absolute best out of generative AI, you really need to break your prompt down into 3 distinct steps. First, provide context. Tell the AI exactly who it's acting as, like, you're an expert cloud instructor. Second, supply the input data clearly. A pro tip here is to wrap the text you want processed in quotes. And third, define the output indicator. Tell it exactly what the final product needs to look like. For example, provide a 2 to 3 sentence summary in a professional tone. But you know what? Sometimes giving instructions just isn't enough. You also need to set up some guardrails, and that's where negative prompting comes in. This is where you explicitly instruct the AI on what it should absolutely avoid including in its response. Because without negative prompting, you might ask an AI to write a short intro and end up with a 5-page philosophical essay. So if you're generating a beginner's guide, you might add a negative prompt that says, avoid discussing detailed technical configurations. Telling the AI exactly what you don't want is honestly just as powerful as telling it what you do want. It keeps the model strictly on task. Section 4. How AI makes predictions. We've talked a lot about prompting models to generate content. But how do these models handle raw data to deliver operational answers? In the industry, this process is known as inferencing.
When you're designing an AI system, you're going to face a really critical architectural choice when it comes to inferencing. Do you need real-time inferencing or batch inferencing? Real-time is for when computers have to make decisions instantly as the data arrives. Think of a chatbot talking to a live customer. Speed is absolutely paramount here. Batch inferencing, on the other hand, is all about analyzing massive amounts of data all at once, asynchronously. So speed isn't your primary concern anymore. Instead, you're prioritizing processing those huge data sets with total accuracy, like maybe running a massive job overnight.
Let's look at a classic real-world use case that perfectly combines both of these concepts: credit card fraud detection. The moment you swipe your card, a real-time inferencing model instantly checks the transaction against your history. It's scoring the likelihood of fraud in literal milliseconds. And if that score triggers a red alarm, it stops the transaction dead in its tracks before it even happens. But then later, batch inferencing might step in to analyze millions of those daily logs overnight, updating the overall model on brand new fraud trends. Pretty cool, right?
And when we talk about the absolute necessity of real-time inferencing, it honestly doesn't get more critical than this. Computer vision powering an autonomous vehicle has to instantly identify cars, pedestrians, and traffic lights. In this scenario, real-time inferencing is quite literally a matter of life and death. The AI model running inside that car's computer simply cannot tolerate any network latency. It has to process the visual data and make a prediction on when to hit the brakes in a fraction of a second.
Section 5. Hardware and measuring success. For our final stop, let's zoom all the way in and look at the physical silicon running all this logic and the math we actually use to grade it.
Remember earlier when we mentioned that deep learning requires massive GPU power? Well, standard GPUs are notoriously expensive and they chew through vast amounts of energy. So AWS went ahead and designed their own custom machine learning chips from the ground up. AWS Trainium is purpose-built to train massive AI models, offering up to a whopping 50% cost reduction. And then you have AWS Inferentia, which is built for the actual prediction phase, the inferencing we just talked about. It delivers up to 4 times the throughput and a 70% cost reduction. These numbers are staggering. It means purpose-built silicon is making AI vastly more accessible, affordable, and honestly, a lot more environmentally friendly.
But how do we know if our newer, cheaper, faster model is actually smart? Well, we measure it. Accuracy is pretty straightforward. It's your overall correct predictions. But that's not always enough. Precision asks a different question. When the model guessed positive, how often was it actually right? Recall asks,
Out of all the actual positive cases out there, in reality, how many did the model successfully find? And finally, the F1 score gives us a really healthy, balanced average of both precision and recall.
We have covered some serious ground today. We've journeyed from the conceptual umbrella of AI straight through generative foundation models on AWS. We've mastered the art of prompting, decoded real-time inferencing, and even looked at the very silicon making it all run smoothly and measurably. The barrier to entry has quite literally never been lower. So, my final question to you is this. With the hardware getting faster, the models getting smarter, and the cloud doing all the heavy lifting, what will you build first? Thank you so much for joining me for this explainer. Keep learning, and I'll see you in the next one.